Use the short link or QR code to download the slides.
This paper by Mary Oliver and Grady Venville reflects on the positive effects CASE has in all of the research done, and in particular the replications they made with Thinking Science Australia. In this presentation, we hope to show just how relevant the pedagogy and practice developed by CASE is to the problems science teachers face on a daily basis. CASE is not just a set of 30 intervention lessons carried out over 2 years. It is an objective and applied theory based on research measuring the cognitive demands of science learning objectives and the cognitive readiness of students. The program applies this research to challenge the development of student thinking. In particular, this presentation will address one of the almost universal problems teachers face. This is the schema of variables in scientific investigations. We will explore the design of the first 5 CASE lessons and directly simulate the 5th lesson rollerball. After this, Natasha will lead a debrief of our experiences and examine some examples of the type of dialogue that this lesson creates. We will finish with a discussion of how the key ideas of CASE can allow thinking and deep learning to flourish in your classrooms. Throughout the presentation, we will be using the 5 pillars of CASE. This will help you understand the way a teacher prepares students for a challenge, uses the challenge to deepen thinking and their awareness of their own thinking, and how to fruitfully apply thinking to new contexts. So pay particular attention to how these phases are used in the lesson we will simulate together. We will give you 3 minutes to think per share about what you notice in the design of the 30 CASE lessons. Remember, these lessons are usually done once a fortnight over 2 years. So you probably notice that each lesson has a low-level entry, a thinking level it targets, and some extension-level activities. Also that as the lessons move to a new schema, the level tends to drop a little. Also that over the 2 years there is a steady growth in demand, and also that the lessons are a challenge above the mean level of student readiness. Now these are the thinking objectives of the first 5 lessons on variables. We will use the vocabulary of the first 4 in the lesson we are now going to experience together, rollerball. As we can see, the rollerball track has a steep side at the left and then a shallowly rising, almost flat side on the right. And we have a place where the target ball can be put. In this case, I've put a medium wooden sized target ball. We also have a place where the roller ball, it rolls down the slope, and we can place it at a certain height. Here I have a white marble, and you see the target ball moves along the track. You might, for instance, put a large marble as the target ball, and up here I've got a wooden ball, medium size, that I'm going to roll down the track. We can do a variety of different variables here. A lower level, the large marble hitting a wooden target ball. And so they're the kind of experiments we can do. Now I'm going to ask you in your group to listen very carefully to the instructions
They will appear in the video after this, but I want you to look at the rollerball track, the different balls, and how we can perform experiments, and to talk about and list all of the variables that you see are possible in this experiment. Remember at the start I said there are 3 input variables and 1 outcome variable, and these 3 input variables can have a lot of different values combined. Okay, so in your group, discuss all of the variables you think are involved in this experiment.
After watching the video, now discuss in your groups what are all the variables involved. What are the input variables and the outcome variable? Look at the slide and starting thinking about the aim of this experiment. Which ball would you release from the high position? Would you release the same or a different ball from the low position? Explain your answer. Look at the slide and starting thinking about the aim of this experiment. Which ball would you release from the high position in order to see if the height makes a difference? You can choose the same ball again if you want to. Explain your choice. Look at the slide and start thinking about the aim of this experiment. The result is the brass ball moves its target ball further than the steel ball does. Does this prove that the brass ball is better for pushing any target ball? Yes. No? I do not know. Choose one of these and then explain why you think this. Why do you think this? Does this prove that the low position is better than the high position for moving a target ball far? Yes. No? I do not know. Choose one. Why do you think this? Now we want to see if the weight of the ball makes a difference to how far the target ball is moved. Result, the target ball in the first drawing is moved further than the target ball in the second drawing. What does this prove? Now you are going to work together for a few minutes in your group and design 2 experiments to try to show how one input variable affects the outcome variable. Look back at the 5 thought experiments we have just discussed Remember, some of them were not very good experiments for some of the reasons we discussed. Then you will explain your design and demonstrate it to the class. What do you notice about the dialogue? Think, pair, share your ideas. Can you see any ways the teacher tried to get students to do some metacognition? Think, pair, share your ideas, and then we will hear from some groups. Can you see any ways the teacher keeps the social construction going? Think, pair, share your ideas, and then we will hear from some groups. A reminder that if you want to download the presentation slides there at the short link, or you can use the QR code, feel free to contact us if you want more information or support. Thank you for your engaged involvement.